come to question number 1. fx equals to 3 by x plus x by 3. Obviously, x is not equal to 0, and then the function is defined. But find the interval where function is increasing and decreasing. fx is a differentiable function. fx is a differentiable function. When x not equal to 0. Now, if we differentiate, what we get? F plus x equal to minus 3 by x square plus 1 by 3. When fx is increasing, f dash x greater than equal to 0. So minus 3 by x square plus 1 by 3 greater than equal to 0. On simplification, this is 3x square minus 9 plus x square greater than equal to 0. So this gives x square minus 9 by 3x square greater than equal to 0. Now x plus 3 into x minus 3 greater than equal to 0 by 3x square. Now on putting it number line, it is minus infinity is infinity. Minus 3, 3, 0. So plus on the ends of the hierarchical point, power odd sign will change, power same, no change, and then again change. So here 0 is what? 0 is the point of discontinuity. So what we can say that for all x belongs to minus infinity, minus 3, union 3 to infinity, f dash x greater than equal to 0. Therefore, fx is increasing in minus infinity, minus 3 closed union 3 to infinity. Next part. Next part is what? Decreasing. fx is differentiable. fx is differentiable function. And uniform function in r minus 0, and fx is decreasing. fx is decreasing. So f dash x less than equal to 0. Now f dash x we have already got x square minus 9 by 3x square. Now less than equal to 0. So we take the number line minus infinity, infinity, minus 3, 0, 3, plus, minus, minus, plus. So here what we have, here 0 is the point of discontinuity. So what we observe here, for all x belongs to minus 3, 0, open union 0, 3, f dash x less than equal to 0. Therefore, fx is decreasing in this interval. Question number 2. Prove that fx equals to x plus 1 by x not equal to 0 is decreasing in, so we have to show this is decreasing in the interval minus 1 comma 0 union 0 comma 1. We have to show fx is, this one is decreasing in this interval. So x not equal to 0 given, it is a differentiable function. Fx is a differentiable function and decreasing. So f dash x less than equal to 0. So f dash x equal to 1 minus 1 by x squared less than equal to 0. Now if you simplify, x square minus 1 by x square less than equal to 0. On further simplification, x plus 1 into x minus 1 by x square less than equal to 0. So if we take a number line, minus infinity, infinity, minus 1, 0 and 1. Here 0 is a point of discontinuity. So plus, minus, minus, plus. So what we observe here, that we need less than equal to 0. So which you get here, minus 1 to 0 and 0 to 1. Because in this region, fx is decreasing. So we can say here that for all x belongs to minus 1 comma 0 union 0 comma 1, fx is decreasing. Now, according to question, we have taken a subset of this one. If function is decreasing here, obviously it is decreasing in any subinterval. So here we can say, according to question, fx is decreasing in minus 1 comma 0 union 0 comma 1. Why? Because if something is decreasing in this interval, that will be definitely decreasing in any subinterval we consider. Now, if you want to see it visually, that is, how does this graph look like, so that you can understand how it is decreasing in this interval. This is x prime, this is the origin, this is y prime. This is the line y equal to x. And here the graph this is 1 comma 0. This is minus 1 comma 0. So you can easily understand that after minus 1 to 0, as the values are increasing, values of x is increasing, values of y is decreasing. And here also you understand that as the values of x is increasing, values of y is decreasing. So obviously it's a decreasing function from minus 1 to 1 excluding 0, because at 0 it's not touching the line y-axis. So this is the visual representation of what we have done. Find the interval in which the function is increasing or decreasing. So fx is given 2x cubed minus 15x squared plus 36x plus 1. Now this is a polynomial function of degree 3. Write down a polynomial function of degree 3 hence a differentiable function. Hence a differentiable function. Therefore, f dash x exists for all x belongs to 1. Now f dash x equal to 6x squared minus 30x plus 36. Now if we take 6 common, x squared minus 5x plus 6. Now on further simplification, this gives us x squared minus 2x minus 3x plus 6. 6 into x minus 2 minus 3 into x minus 2. Now this is 6 into x minus 2 into x minus 3. We take the number line to represent this. Minus infinity, critical points are 2 and 3. Plus on the right hand side, the highest critical point for odd sign changes. For odd sign changes. Now, after this, we can say for all x belongs to minus infinity comma 2 union 3 comma infinity f dash x greater than equal to 0. So fx is increasing in this interval. Fx is increasing in this interval. And for all x belongs to 2 to 3 closed f dash x less than equal to 0. So fx is decreasing. Fx equals to x cubed minus 12x squared plus 36x plus 7. Right. Fx is a cubic polynomial. Hence a differentiable function. In R. So we find f dash x 3x squared minus 24x plus 36. We take 3 common. X squared minus 8x plus 12. We further simplify x squared minus 6x minus 2x plus 12. Now 3 into x into x minus 6 minus 2 into x minus 6. Now here 3 into x minus 2 into x minus 6. Now if we take a number line, minus infinity, this is infinity, 2, 6, plus odd power sign changes, odd power sign changes. Now we need increasing and decreasing. So what we can say here, for all x belongs to minus infinity comma 2 union 6 comma infinity, f dash x is greater than or equal to 0. Therefore, fx is increasing in this interval. Again, for all x belongs to 2 comma 6, f dash x less than equal to 0. Therefore, fx is decreasing in this interval. F of x equal to x cube minus 6x square plus 9x plus 15. Here fx is a cubic polynomial. Is a cubic polynomial. Hence, differentiable in R. So f dash x is 3x squared minus 12x plus 9 x squared minus 4x plus 3. Sum of the coefficient is 0. So 1 is a root. Other root is 3. Now we plot them in the number line. 1, 3. Plus, odd, sign changes, or sign changes. So for all x belongs to minus infinity comma 1 union 3 comma infinity, f dash x greater than equal to 0. So fx is increasing in this interval. And for all x belongs to 1 comma 3, f dash x less than equal to 0. So fx is decreasing. That's it. Now here, the sum is easy. Just you can see here that when sum of the coefficient is 0, we can directly say one of the root is 1, other is 3. That's fx equals to x squared minus 6x plus 7, which is a quadratic polynomial. Which is a quadratic polynomial. Hence, differentiable function. In R. So f dash x is 2x minus 6. When fx is increasing, f dash x greater than equal to 0. 2x minus 6 greater than equal to 0. implies x greater than equal to 3. So x belongs to 3 comma infinity when function is increasing. And when fx is decreasing, then f dash x less than equal to 2x minus 6 less than equal to 0. X less than equal to 3. So x belongs to minus infinity comma 3 when function is decreasing. Fx equals to 2x cubed minus 3x squared minus 12x plus 4. Fx is a cubic polynomial. Fx is a hence a differentiable function. Hence a differentiable function in R. And f dash x equal to 6x squared minus 6x minus 12. 6 taken common, x square minus x minus 2. 6 into x square minus 2x plus x minus 2. X minus 2 plus 1 into x minus 2. 6 into x plus 1 to x minus 2. If we take a number line, so it is minus infinity to infinity, minus 1 to plus power odd sign changes, power odd sign changes. So for all x belongs to minus infinity comma minus 1 closed union 2 to infinity, f dash x greater than equal to 0. Therefore, fx is increasing. And for all x belongs to minus 1 comma 2, f dash x less than equal to 0. So fx is decreasing. Fx equals to 4 minus 9x plus 6x squared minus 6. Here fx is a cubic polynomial. Fx is a cubic polynomial. Hence, differentiable function. Hence, differentiable function. So f dash x equal to minus 9 plus 12x minus 3x squared. We take minus 3 common. X squared minus 4x plus 3 minus 3 into x minus 1 into x minus 3 because sum of the coefficient is 0. Now we take a number line. Minus infinity infinity. We start with minus power or sign changes, power or sign changes. Now here why we have taken the minus, because we have a minus symptom. Now what we can say, for all x belongs to 1, 3, f dash x greater than equal to 0. Therefore, fx is increasing. And for all x belongs to minus infinity union 3 to infinity, f dash x less than equal to 0. Therefore, fx is decreasing. Fx equals to sin x minus cos x. X greater than 0, less than 2. Now, here obviously sin x and cos both are differentiable function. Sin x and cos x are differentiable function for all x belongs to 0, 2, 5. Therefore, fx is differentiable. As difference of two differentiable functions is always differentiable. So we differentiate, we get cos x plus sin x. Now after this, it is better to draw the graph of this and then conclude. So here we can convert this to root 2 sin x plus pi by 2. Now, since it is plus pi by 4, that means the whole sin x graph, if we draw the sin x graph, this is the sin x graph in 0 to 2 pi. This graph should be shifted pi by 4 to the left, this pi by 4 plus, or you can think in this way. So here when x is 0, sin x is 0. When this will be 0, when minus pi by 4, so it will be shifted by 4 unit towards left. So if we draw the corresponding curve, this will be like this. The nature is like this. So here this will be pi by 4. This will be 3 pi by 4. This point will generally 3 pi by 2, but pi by 4 has been shifted to the left. So that is 5 pi by 4. This point, which is generally 2 pi, pi by 4 has been shifted left, so this is 7 pi by 4. And here we have. Now, f dash x, why it is positive? In this region positive, and here positive. So what we can learn, that for all x belongs to 0, 3 pi by 4 union 7 pi by 4, 2 pi. Here 0 is the open bracket because in the question they have not enclosed 0, so you cannot take 0. So here f dash x is greater than 0, because we can see this part of the curve is above x axis, and therefore here fx is increasing. Now, this part from 3 pi by 4, 7 pi by 4, f dash x is less than 0, so it is decreasing. Whereas in this case, f dash x when less than 0, this part, so here function will be what? Function will be decreasing. So we write it down. For all x belongs to 3 pi by 4, comma 7 pi by 4, f dash x is less than equal to 0. Therefore, fx is decreasing in this interval. Now, if you want to see that, okay, we have got the interval, it's fine, but this is the interval where we have got increasing, decreasing. As we have drawn this graph, when x plus something and shifted that much to the left, same way, that is this graph is y equal to cos x plus sin x. Now, similarly, we can draw this graph and understand whatever we have got, that is correct or not. Now, y equal to sin x minus cos x can be written as root 2 sin x minus pi by 4 y x y prime x prime origin. Now, here what will happen? We know at first you can draw sin x graph. Now this graph will be shifted pi by 4 towards right, and we get this. Now, and this part is because we have take from 0, so this. Now we take here pi by 4. This is 3 pi by 4, and this will be, this is the why 3 pi by 4? Because 3 pi by 4 minus pi by 4 is pi by 2, so you get the maximum value here. Now, this point is generally pi, but it has been shifted by pi by 4. So this is 5 pi by 4, pi plus pi. Now, this point is generally 3 pi by 2, that is 6 pi by 4. Now it is 7 pi by 4, because pi by 4 has been shifted to the right. And 2 pi will be somewhere here. Now, according to our observation, from 3 pi by 4 to 7 pi by 4, function is decreasing. Obviously, that is true. From here, if we see that this part of the curve is definitely decreasing, and the other part which are we left with, that part is definitely increasing. You can see. So this is the graph of y equal to sin x minus cos x, and for only x lying from 0,